In this video, we will see some of the properties of scalar dot product in vectors. The scalar product of two vectors is commutative, which means the vector A dot product with B will be equal to vector B dot product with A, and it can be easily illustrated with a simple illustration. A dot product with B is nothing but magnitude of A magnitude of B into cos theta. Reversing magnitude of B and A, we can rewrite it as magnitude of B into magnitude of A into cos theta, which is the same as B dot product of A. That is, for any two vectors A and B, A dot product with B is equal to B dot product with A. The nature of scalar product, we know that theta, which is the angle between two vectors for which we are going to find the dot product, ranges from 0 to pi. So let's first see each case when theta is equal to 0. When theta is equal to 0, then our A dot product with B will be equal to AB. So when theta is equal to 0, which means, let's consider this is our vector A and this is our vector B. So when theta is 0, that means vector A and vector B are in the same parallel lines. So the two vectors are parallel, therefore theta is equal to 0. So our A dot product with B will be equal to A times B. The second scenario that we will consider is when theta is equal to pi. So when theta was 0, A and B were literally coinciding with each other, and when theta is equal to pi, which means our vector B will be in this direction, which means they will be parallel but in opposite directions. Therefore, our cos theta will be a negative value. In other words, our A dot product with B will become minus AB. And when theta is equal to pi by 2, which means the angle between A and vector B will be 90 degrees. So if it's 90 degrees, then the two vectors are perpendicular. So then our A dot product with B will be 0, which is evident from this. The impression or the projection that OB or vector B will make on A will be 0. Therefore, the dot product A dot product with B will be 0. Further, we can infer if theta is between 0 and pi by 2, then cos theta is positive, and hence A dot product with B will be positive, which is if theta is from 0 to 90 degrees, which is pi by 2, then the cos theta will be a positive value, and so will be our A dot product with B. However, if theta is between pi by 2 and pi, which is from 90 degrees or pi by 2 to pi, then our cos theta is a negative value, hence A dot product with B will be also a negative value. So if our A dot product with B is equal to 0, we can derive three conditions in this. First, it can mean that our A magnitude is 0, or we can assume that the magnitude of B is 0, or the angle between them is 90 degrees. So if the two vectors A and B are non-zero, which means their magnitudes are not equal to 0, just as in the previous case, then we can say if A dot product with B is equal to 0, then vector A is perpendicular to B. The different ways of representation of A dot product with A is, we can call that as the square of the magnitudes, because cos theta will be 0, therefore A magnitude squared will be the answer for this. It can also be written as vector A squared, or within bracket or without bracket, and it can also be written as just the A square, which is the length of the vector A. These representations are very essential while solving problems. Next, we can prove that I dot product with I is equal to j dot product with j, and it's equal to k dot product with k, which is equal to 1, and also I with j and j with k and k with I dot products are all equal to 0. This illustration is already given in the other video, and its description is in the description box, or its link is in the description box. So if you want to see how this is achieved, you can watch that video and that will help you. If vector a and b are multiplied using two scalar lambda and mu, then you can express them as, in this case, like how lambda mu a dot product with b, or you can put within bracket lambda mu a vector dot product with b, or it can also be expressed as vector a dot product with lambda mu b vector within brackets. All these are possible. Next, the scalar product is distributive over vector addition. That is, if any three vectors a, b and c, we can say that a vector dot product with b plus c is equal to a dot product with b plus a dot product with c. So it is left distributive. Similarly, a plus b vector dot product with c can be written as a dot product with c plus b dot product with c. So it's also right distributive. Subsequently, we can also, interchanging the plus sign to a minus sign, we can say a dot product with b minus c is equal to a dot product with b minus a dot product with c, and a minus b, the dot product with c, is equal to a dot product with c minus b dot product with c. These can be extended to any number of vectors. As our ninth case, we can describe vector identities in these following manner. Let's take the first case, which is a vector plus b the whole squared can be written as vector a magnitude squared plus vector b magnitude squared plus 2 times of a vector dot product with b. Similarly, if we change the sign to minus, it will follow the same pattern. It's just that it's the same as the a minus b the whole squared formula. Similarly, a vector plus b vector dot product with a minus b vector is equal to magnitude of a squared minus magnitude of b squared. Now let's see the illustration for the first case alone, and the rest you can derive in a very similar manner. So by the property of 3, which we have done it earlier, we can say that a plus b the whole squared is equal to a plus b dot product with a plus b, which means, doing the distributive law, we can say that a squared plus b squared plus a dot product with b and b dot product with the a. Further expanding this in this manner, you can rewrite it as a squared magnitude plus b magnitude squared plus 2 times of a dot product with b, because they are commutative. Further, we will see the working rule for scalar product of two vectors. So this is very useful in finding the dot product. This will be mostly used whenever you're doing two vectors dot product when they are position vectors. So if, like, vector a is equal to, given by this, and vector b is given by this, they are both position vectors, then a dot product with b dot product can be written in this form. Now further applying our distributive law, we can expand this. Now when you expand this, you will find we have I dot product with I, which is 1, value 1, then I dot product with j, which is here, this will be 0. Similarly, this will be 0. So further applying this, you will find our result will be a1 b1 plus a2 b2 plus a3 b3. Therefore, the scalar product of two vectors is equal to the sum of the products of their corresponding rectangular components. Further, the dot product can also be used to find the value of theta, which is the angle between the two vectors. So theta is the angle between vector a and b. Then we can define theta as cos inverse of a dot product with b divided by magnitude of a into magnitude of b. Property number 12. For any two vectors a and b, we can say that the magnitude of A plus B vector will be less than or equal to vector A magnitude plus the magnitude of vector B. You can use the triangle property for this. So if you have a triangle and you have vector A and B, then the third side cannot be longer than the other two sides. So you can say that A plus B, which will be the third side, cannot be bigger, or it is less than or equal to magnitude of A plus magnitude of B. Similarly, for any two vectors, we can say that A dot product with B, their magnitude is less than or equal to magnitude of A times the magnitude of B. How can we prove that? If one of them is 0 vector, then the equality holds. So if this or this is 0, then this is less than this. However, let us assume that they both are non-zero vectors. Okay, so what we have cos theta is equal to A vector dot product with B divided by the magnitude of A into the magnitude of B. So if we are going to take the mod value of A dot product with B, we know that A dot B is a scalar quantity. So if we take the mod of that, then we can say this is equal to the mod value of cos theta. So this we know will always be less than or equal to 1. Therefore, our A dot product with B has to be less than or equal to magnitude of A times magnitude of B.
Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.